Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome back to online NPTEL course on structure, form and architecture, the synergy. Today we are at lecture number 16 and in this we will talk about the structural typology. So, in the last lecture we have discussed about different material and their pros and cons, and also we discussed about different properties. So, looking at their property and then advantage disadvantages. So, time to time we develop different structural arrangement. So, in earlier lecture we have discussed about like post column, post slab, wall slab. So, this kind of different structural arrangement that being in practice and we create the overall structure. So, in this it will be another interesting lecture where we just discussed about different type of structures, and then this lecture will be basically a summary or maybe a what we can say that a very brief introduction to different type of structural system, and slowly we will pick up one by one and we will discuss on that and their application. So, let us start this particular lecture. So, if you like try to make structural category, so it is very tough. We cannot really have a single category of a structure, because when we discussed about the structural form, that time also we said that structural form is something like not really giving the clear picture. It is better the structural system, because a building may have more than one such structural system. So, one may be predominant, but the other is also important as well. So, looking at that position, looking at the material used. So, in this particular lecture we try to divide it in 5 categories. So, what are those categories? The first one is a solid type structure. Okay. The second one is surface. So, then we talk about something having lower thickness, and then the skeletal is basically similar to the skeleton. So, the given the backbone, and then the remaining part of overall building is just to protect the environment or making privacy and etc., like the frame structure and all. Then also there is a category called membrane structure, where we normally will be talking about the tent, the cable, some pneumatic structure, we will discuss on that. And the skeleton, it is the framework and the truss, different kind of truss. We will also discuss each of them in a separate lecture to know more about that, like how they really helping us, like how they deal with the applied load, where the compression will develop, where the tension will develop, how it will act against the bending and the shear. So, we will also discuss on that, but for this time being we just try to figure it out. So, when we talk about the solidness, so we just can collect it with the wall, then the arch and the vault, and then you have your what we call the dam. And then when we talk about the tension assist structure, so it is hybrid. So, not coming into the single category, it may be something like which is a hybrid of multiple such structural systems. So, we use the membrane, we use the like some skeleton, and then we just make a fusion of that. So, that is basically what we can say the classification into the category. So, in this before we really go, so solidity, so it may be what we just told, like this is the wall structure, then you can support it with some buttress in like earlier in history we have used it when we talk about like the surface. So, we are talking about different plates or the slab or the connection between your column post slab kind of combination. So, this is another typology. When you talk about the membrane, so basically we are talking about the different membrane structure which is anchored somewhere and may be supported with a mast. So, this is in this category. And then if you go for like the skeleton structure, so it is basically the frame that we make, the composition of your horizontal and vertical components. So, let us discuss with some examples, so it will be clear to us. So, in this wall are the simplest form and basically it is the compressive structure, and the way they will transmit the load is basically towards the gravity. So, whenever we create any building and also finally whatever load imposed on it will transmit to the foundation it has, it may be the step foundation for the load bearing or the isolated if it is something made of the other type of foundation. So, it transmit the load vertically downwards. The construction is normally the masonry or in concrete. So, when we talk about the brick wall or the stone wall, so it is related to the masonry. So, they put brick or blocks on the mortar bed and they form this particular structure, and can also act as a retaining structure if we properly ribbed it with the reinforcement. So, nearly where we want that retaining structure, maybe at the bank of the river or maybe somewhere in the hilly region where to protect the landslide. So, wherever we require, the similar kind of retaining wall can also be used. The shear wall can also be used in this category, which basically is showing a mass and solid profile, sectional profile of a structure, and hence it is coming under this solid category. So, here you can see a example, random example I have taken. So, it is mostly the wall, the the nice masonry work that create all these openings and all. So, overall aesthetically it is looking very pleasing, as well as it is also solving the purpose of the structure. Come to the arch, fault and dam. Again arch is again very useful, like what we can say, the compressive structure where due to its curvature it transfer the load. So, load is very well transferred, and because of the symmetry of this arch, it will transfer the load to the the supporting column, and then it transmit the load. So, as true with the vault, where we can also get this kind of compression mainly in this category, and same is true for the dam, where it is being built very huge, and it may make of something like concrete, the retaining wall, or maybe sometimes in earlier it is just like a masonry. So, it is under the profile of the solid structure as a typology. Now, come to the surface one. In this basically it is not that much solid. So, what grid says that it is a series of members arranged at right angles to one to each other to form the grid. Okay. So, it is the arrangement, but depending on the arrangement we may have a regular or rectangular grid like this, or maybe we have something which is skewed and sometimes in 45. So, that may be a diagonal grid. So, basically whenever we design a building, so we design the beams layout support to the column in different way out. So, we make the grid, and this grid this particular frame structure will really help us to make multi-story. So, in this grid will decide about the span, and also it decide the direction how load will be transferred. So, the shear it sheared the loads according to the position and direction of the members which are close to it, which are away from it. So, if I take say one square slab in a grid, So, basically if load is imposed here, so how it will be distributed is basically distributed like this. So, it will transfer the load to the beam, and it is very very systematic manner. If the material is very homogeneous and all the columns designed to support it are equal in size, so it will also be distributed very uniformly, provided that it is uniformly distributed load. But whenever it is point load, it will self adjust to its position. So, it is also can be used for the large span where this grid can be formed, and then also for the height. So, here you can see one of that, like how grid being used in this structure. Come to the second example under the surface, where it is basically showing about what we discussed earlier also, that is your post slab connection. So, you can see that there is no such beam or something, just the slab is resting on the post or column. So, plates or flat slab are generally horizontal element, as because we call it slab, and with the length and breadth. So, this is we just define it with certain area, and it is large in comparison to the thickness. So, this is how you can define it. So, whenever you think about say 5 meter by 5 meter grid, so thickness is compared to that is 150 mm. Okay, so where it is 5000 by 5000. So, it is like that, even it can be higher based on the requirement and the material used. They are designed to span in two direction at right angles and may be flat. So, sometimes it is how you go for it, like it may be something we will come that like the one way slab or two way slab, and depending on how we design this particular thing, like length is too big, or maybe it is having equal share all the side like squarish form, and then stiffening strip and the thickening at the supporting column points, that will also determine the characteristics of this plate. Slab can be designed around lines, equal stress, but formwork is elaborate and thus expensive. So, we can really go for this kind of grid, but basically that needs the proper calculation, that computation to be done, and then also we have to decide about the formwork or the supporting work during the construction, when the concrete and other thing is in initial setting in the semi liquid form, then we have to take care of this. Come to the other surface category, when again the thickness of that particular form is so negligible compared to the span it can cover. So, shell are the surface structure which are curved in one or two direction. So, like it may be of say something we just bent a piece of paper in one direction like this. Okay, if I draw it correctly, so something like this. So, we just bend it, give a form of a vault. So, that is one, or it may be like two directional, where we think about in this case that one curve is in this side, the other one is this side. So, like we play with the parabolic, hyperbolic or hyperbolic paraboloid form, that if you find the work of Felix Candela, we find that kind of use of the curvature. So, in that this curvature will help us to also resist the load implied on that, and also it can increase the huge span, and also like due to the thin this particular shell can help us to design. So, you can also think of a dome where it can develop it. So, in this case like the hyperbolic paraboloid shell being used in many buildings that we can see. The structural forces in shell are largely pure tension and compression. So, basically in this case what we have, that a surface where this will be in compression, this portion, and then at the bottom one it will develop tension. So, it is to be understood, like if you take a particular such kind of domical shape and you just put pressure on that, or you take one eggs. When we discussed about the cell structure, I will really show you some of the experiment at a small scale, that how we understand where tension and compression will take place. So, this is another typology under the surface. Now, in this case this is surface where it is the stress skin. So, what exactly it is, basically not a flat one, but it is related to something where we already have seen, like the folded plate. So, already it is a combination of thin plates, like how you add the ribs or increase the stiffness of that material. So, it may be some corrugated metal pipe, or it may be something where it is a membrane kind of structure. So, ribs contribute stiffness, and also like what we can get out of it, the thin and flexible sheet that can also be acting better due to the applied load. So, depending on the material availability and the purpose, will pick up this kind of stress skin. So, here what it says, the materials used for stress skin construction can be metal, timber or GRF. So, basically in this case, like wherever we can really do this experiment, but at the same time we can also use the concrete in this case, but properly it should be ripped or reinforced in this case. So, it is again from the surface example. Now, come to the skeleton. So, this is a very useful component under that, that is the truss. So, truss is basically assembly of structural members. Okay. So, they are joined together, and mostly they are joined together with a pin joint, okay, and this is to be formed in a triangulation form. Because to start with, suppose we have a portal like this where they are fixed. So, on applied load, what happened, that it will try to get a deformation the moment we put a diagonal. Okay. So, automatically this, due to this triangulation, so it will be more it will develop more resistance against applied load, and this particular arrangement, the bracing we call, okay, help this structure to get better stability. Trusses can be two dimensional, like normally this kind of two dimensional truss being used for the factory or some old historic building, and it may be three dimensional, and then we call it prismatic, and when it is two dimensional we call it planar. So, here this is the example of planar truss, and here it is true two dimensional or prismatic. So, here you can see this basically this kind of structure where the cross section, if you see, that will give a form of a prism. So, from that it is derived as prismatic. So, for any cultural event, some concert, you must have seen this kind of arrangement where with the minimal area this is so stable. So, this is one. So, prismatic or space truss linked together. So, when we use this 3D truss, it will give a form of space frame. So, space frame is another important structural typology being used to have a light roof, especially for a gathering or maybe station or an airport. Now, in this case, like this is one example of the space frame. You see like how they are joined to each other. The load transfer of this space frame, how the transfer is complicated, it to be designed very accurately, and then you have to apply it, and there are few supports, so that you can see that the how much span and the height it can cover. So, space frames are three dimensional lattice structure, linked pyramid or tetrahedra. So, basically tetrahedra is where all these vertex, they are equidistant to each other. So, that is one important, and it is giving a very good stability instead of a pyramid of different height and all. Now, load span, the edge condition determine the form and depth. So, definitely how you really try to fix it up, how you transfer the load, based on that this will be designed. So, this is another skeleton structure typology that being used for the building. Now, come to the framework. So, here again it is a composed of materials which assembled in 2 or 3 directions. So, we just try to make a box. So, it may be something like we just connect this part and then this part, or maybe they are connected to give more rigidity, more stability with this bracing. So, stiffness of a frame depends on the stiffness of the element that we used. So, how you use this particular material and like this member or this element to that system, that will determine the stiffness. The pin joint frames are unstable under load and require the addition of further element to give stiffness, like diagonal bracing. So, what we discussed, like we can have a frame like this, just simple frame, and they are pin joint. So, they will definitely deform, and then if we add this, so it will be stable. If you go for a cross bracing, so it will be more stable to that. For high rise buildings, its lateral force is concerned due to the wind, and again due to the seismic activity, the oscillation. So, this lateral movement of the structure is very important for high rise, but for especially considering the wind blow at higher altitude. So, this kind of bracing to the framework, so definitely help us to come up with better solution to resist our building against that kind of applied load. Now, come to the membrane. This is a type where it is already being discussed, and this example from the Arizona State University campus being so repeated, so nice construction with some kind of cloth like material. So, it is fully given the tension. So, with this tensile cable and this the mast that used is only act as the compressive members. So, in membrane structure, all the primary forces are arranged to be in tension through the cable, and the form cables and or a net and coated fabric with tension edge cable. And whereas the load from membrane can be taken to the ground via compression mast. So, this is the compression mast. So, they have used in several points, and others, all members, all this coated fabric is basically in tension. Now, compared to that, the other category in the membrane structure, that is the pneumatic structure, where like air or some kind of liquid being pumped. So, for pneumatic, it is most commonly the air supported membranes, and they do not really need any other support or any form. So, they will be created. So, we put the air, and many of us we have seen such kind of pneumatic structure, especially in a fairground or something for the kids, that we find a Mickey Mouse or something, student are jumping on top of it. So, it is basically a cloth or such fabric, and we just inject air into it and give the tentative form. So, this is another kind of membrane where the thickness of the material is nothing, but to create the form, the huge space is very vital for us. There are some disadvantage of this about the height restriction and the reaction against other forces, but definitely it is one of the very portable structure that we can develop. Now, come to the hybrid structure. So, in this the hybrid structure basically where the number of structural types do not fit in the category that membrane or the like we said solid or the skeletal. So, that is coming into the hybrid category. It is a fact that although primary type may be solid or skeletal, but secondary elements of different type may part of the structure. So, we cannot really distinguish or put a structure in a single category. So, same example can be given in multiple category, but looking at the predominance of a structural system, of all structural systems being used in this building. So, we put in the category, but in hybrid there are more than one is basically the dominance. So, here it says the hybrid where there is a combination of two types of near equal dominance. So, if you see this structure, that here this particular glass space frame being used and as well as this steel framework being used. So, both are complementing each other. So, here it is coming under the hybrid category. So, in that there are probable compositions like what we can call the tension assist structures. So, this is basically it may be a steel or tensile members. So, only steel being used as like post beam, and then the cables being used to add some membrane kind of structure to it. Then you may have the structural glass and steel as a combination. Here you can see what exactly like it is being still being used with other. So, then in this also the masonry and steel can also go together. Okay. So, this is something like where you have seen like in earlier phase that we make the masonry with the brick and all. We do not really cast the slab with a concrete or something, we just use some I section. So, on top of the wall of a building of the masonry, we put this I section in layer. So, basically if I draw the plan, so many I sections are running parallelly, and on top of it we put the tiles and that put some lime concrete to make something like what we also can call reinforced brick concrete or something or the other. So, it may be something like where we use the timber and steel together. So, in particular lecture we have discussed about like how we make the timber as a structural material, and we make the whole building with the timber material, the beam, column, the bracing, and rest of the things are filled up by the masonry. So, it is again a combined structure. So, even in the load bearing case, so we put both together. So, this is something where like we go for making it a very hybrid structure. So, this particular thing is under hybrid. Now, to have a quick recap in this portion, like let us just try to understand this predominancy of this structure. So, if you use this particular example TWA terminal building, so it is coming under I just give you some few seconds to think on it, and then let us just match whether we are on the same track or not. So, take some 5 seconds and just quickly just figure it out. Okay. So, I think all of you can give right answer to that. So, it is basically compared to the it is coming under the shell structure, thin shell structure, and it under the category it will come in the category of surface. So, surface and shell. This is again surface, right. So, it is again surface, but in this case it is basically the folded plate, and this is something looking very attractive. So, it is based on the air. So, it is pneumatic. So, it is pneumatic structure, and the category is your membrane, right. So, okay. So, this task is done. I think all of you have answered in a similar fashion. So, let us take another set. So, in this case what we see like what exactly it is? Yes, it is basically the space frame, right. So, space frame is basically coming under your skeletal structure, fine, very fine. Again, this is something which is made of some concrete reinforced and creating the dome. So, again it is coming under shell structure. Okay. And then also it referred to surface because of the thickness of that particular its thickness is very less compared to the span it can cover. Now, here it is something like, can you recognize this particular picture? I have used a couple of times this earlier. So, this is the Olympic Stadium from Munich, and we discussed on the ground of making a light structure. So, it is again, if you see that, okay, there is post and then the cable, and then it is basically the membrane that are looking this is most prominent. So, it is again a membrane structure, okay, where it is basically given tension, and then all this load transfer to the ground through this compressive mast. Okay. So, it is compressive mast. So, we know this thing. So, now your task is to really find some buildings that you see in your day to day life, or maybe you have come across through different platform in a book, or maybe in some website. So, you just try to figure out and just put them in the category. So, make a exhaustive list and share with me, so that we will discuss on that in the process. So, this is what that we discussed about this, but again the summary what we can say, that though we have the category of solid, then you have this surface, then you have this membrane, then you have skeleton, then after that you also discussed what we like have, this is basically the hybrid. Okay. So, these are some general form, but we cannot really give a single name to a building, because it may consist of multiple structural system. So, but predominance, looking at the predominance which is coming up in front of you, we will go for that. So, your task is to find or give put that building that you search for, or you have already noticed in different platform, to club into together. So, again I really thank you all to take part in this course, and now we will be waiting for the further discussion of each of individual structural components on that. And before that, you can really go through the books that I have referred, which are very useful to get more examples, and also help to develop the idea on the discussion that we have. So, next we will discuss with compressive structure, and till then again I would like to thank you. Bye bye.